Good afternoon and welcome to this video on kinematics. Now, if you see the title, this is kinematics on a page. So this is to give you a broad perspective and a big picture of kinematics. See, if you were in class 9th, you would study uniform motion, which means there is no acceleration, and the formula of distance is equal to speed into time, and velocity into time for displacement are applicable since a is equal to 0. In class 9th, you also study about uniformly accelerated motion, where you have acceleration and the equations of motion, to study the motion, to analyze the kinematics variables, which are v, u, a, t, and distance, displacement. We use these equations of motion to describe the motion. But when you reach class 11th, the motion which you study, on top of uniform motion and uniformly accelerated motion, is also the non-uniform accelerated motion, which means the acceleration is varying. It changes with time. It can increase with time. It can decrease with time. Now to solve non-uniform accelerated motion, and analyze it, there are two techniques. One is a calculus, the other is graphical. Depending on situation, you can choose either of these. The techniques which are, for example, calculus is not taught in class 9th. It is taught only in class 11th. So whenever you think of calculus, there are two types of calculus. One is integral calculus, the other is differential calculus. So when you hear the words instantaneous, area under the curve, and it's a non-uniform accelerated motion, typically you're talking about non-uniform accelerated motion, and therefore using these techniques such as integral calculus and differential calculus. So pay attention to this slide, pause the video, go through every word of this to get your head around the fact that you're talking about three different types of situations, and one concept does not get applied on other situation. Your first job is to understand which type of motion it is and then select the appropriate type of technique. Thank you very much.